In this demo, we'll learn how to register an open generic service with the Microsoft Dependency Injection container. An example of where this is used by the framework is with the iLogger of T interface, which is implemented by a logger of T. Classes can depend on an iLogger of T where the generic type argument is their own type. Each generic type gets its own runtime instance, allowing the type information to be utilized to set the logging category for any log messages. Registering these manually for each type would be quite tedious, which is why the Microsoft container supports the registration of open generics. In the tennis booking application, we'll follow a similar pattern to register a wrapper around a distributed cache. Here's the generic interface for the iDistributed cache of T. The implementation of this interface uses the generic type parameter to build a cache key prefix, which ensures that keys for different types are unique within the cache. To avoid showing a new greeting to a logged-in user each time they revisit or refresh the bookings page, we could add a cache to store the random greeting for each user. Inside the bookings model, we can accept an iDistributed cache in the constructor. The type we need to cache in this example is the user greeting record. After creating the private field, I'll paste in a code block that updates the onGet method to use a cached value for the greeting whenever it's available. The cache key ensures that we cache a greeting per user. If a greeting is found in the cache for the user, it's used to set the greeting property on the page model. Otherwise, a new random greeting is generated and then cached. We must ensure that we register our generic distributed cache service with the container. Based on what we've learned so far, here's a possible registration that uses closed generic arguments for the iDistributed cache service type and the distributed cache implementation type. This is an explicit registration, and it works if we only have a single type that we wish to cache against, as the closed generic argument here means that this only applies for the user greeting type. What happens when we need to cache other types? Using the current approach, we would need to manually register a new registration for each type that we could potentially need to cache. A better way to approach this problem is to utilize open generic registrations with the container. This allows us to define a single registration that the container can use to resolve an iDistributed cache for any possible type argument. We can't achieve an open generic registration using the generic try_add_singleton method. Instead, we'll provide the service and implementation type information via an overload, which accepts them as method arguments. We can use the typeOf expression to pass an open generic iDistributed cache service type for the first argument. We can do the same for the implementation type, providing the type for a distributed cache with an open generic argument. When a service is resolved at runtime, the generic type argument will be provided, and the container can create the appropriate generic implementation type. We can run the application, and if I visit the bookings page, I can refresh it several times to check if we see the same greeting. Indeed we do, as the greeting text is now cached for 60 minutes. In this demo, we'll create extension methods to improve the cleanliness and readability of the configure services method. As our application has grown in complexity, so too has our program class containing our registrations. In time, it could be filled with many tens or even hundreds of lines of code needed to register all of the required services. This can make navigating through the service registrations quite confusing, and it's easy for things to get lost in the noise. When we reach this stage, it can be worthwhile to spend a short amount of time improving the structural organization of our registrations. There are some quite distinct themes in our existing registrations, with groups related to common functionality. Take, for example, these registrations, which all relate to the booking rules for the application. Let's add a new folder to the project called Dependency Injection. Inside this folder, we'll add classes that provide extension methods for the iService collection that will allow us to relocate and group related registrations. The first class we'll add is going to be named Booking Rules Service Collection Extensions. I'll make this class static and create a static extension method inside it. This method will return an iService collection, which supports fluent chaining of calls. We'll call this method add booking rules. The use of add followed by a description of the feature that the method registers services for is a pretty standard naming convention. You'll likely be familiar with the call to add Razor Pages, for example, which is an extension method that registers all of the required MVC services needed to use the Razor Pages programming model. The only parameter for this method will use the this keyword to identify the type that this method is extending. In this case, we're extending the iService collection. With the skeleton of our method defined, I'll jump back to the program file and cut the group of registrations that relate to the registration for booking rules. I can then paste these into the new extension method that we've just created. I'll also cut and paste the registration for the booking rule processor, which is very closely related to these rules. Finally, our method signature says that this method will return an iService collection, so we can return the iService collection that the method's been called on. As a reminder, we're returning the iService collection from this method in order to support the optional use of method chaining within the program class. The built-in extension methods are also designed this way. Inside the program file, we can call the new extension method. Several lines of code have been reduced to a single line, and already the code is looking less cluttered. It's now a case of simply repeating this process for the rest of the registrations. Because our extension method returns the iService collection we're operating on, we could opt to call subsequent methods here without accessing the services variable each time. Chaining method calls is not required, but some teams may prefer the more succinct format. I'm not going to make you watch me refactor everything here, and instead I'll leave that as an exercise for you to try in your own time. Once you've created the extension methods, don't forget you can also try out method chaining as well. I'll include an example of a fully refactored program class in the exercise files, which you can refer to if you need to. This technique is beneficial for library authors, whether building public NuGet libraries or those used internally to share common functionality between applications. By including an iService collection extension method in your library, you can provide a simple way for consumers to ensure that all of the required services get correctly registered. We've covered a lot of advanced scenarios now, so please take a few moments to play with the examples and thoroughly understand them. Join me in the next module where we'll explore how and where services can be injected and resolved in ASP.NET Core applications. Welcome back. This module will continue our journey, focusing on injecting and resolving dependencies. We'll begin by learning about the locations where services can be injected via constructor injection and the rules for injecting into constructors. We'll look at injecting services directly into action methods and why this may be useful. We'll learn about the two approaches for injecting services into middleware components, and we'll explore how to inject services directly into Razor views. We'll also learn about injecting services into minimal API handlers and into background or hosted services. This will include understanding how to manually create scopes from which we can resolve services. ASP.NET Core activates and resolves services via two mechanisms. The most common in many situations will be via the iService provider directly. In this case, services must have first been registered with the container in the program file. When a dependent class requires an instance of a service, an instance will be resolved from the container. The second mechanism of activation is via the static activator utilities class. Activator utilities is used to create objects that have not been registered into the container via several static methods that it exposes. Activator utilities will attempt to create an instance of an object using its constructor. Arguments for the constructor can be supplied directly, or they may be resolved from an iService provider. The framework uses activator utilities internally to activate some framework components. Controllers, tag helpers, and model binders are just a few examples, and these are not registered into the container by default. You should rarely, if ever, need to use this class directly in your own code. So far in this course, we've seen that dependencies can be injected via constructors. Constructors will likely be the most common place where services are injected and resolved in your own applications. You can inject dependencies into the constructors of controllers, Razor page models, view components, tag helpers, filters, middleware, and more. Any classes from your application registered with the dependency injection container can also accept dependencies via their constructor, which are injected at runtime. Constructor injection is straightforward and very convenient to use. A few rules must be observed when using constructor injection with the Microsoft Dependency Injection Container in ASP.NET Core. If constructors accept arguments that are not provided by dependency injection, then default values must be provided for those parameters. The defaults will take effect in cases where the container needs to create the object. Constructors must also be public to support dependency injection via both the iService provider and the activator utilities class. In cases where an object is being activated by the framework using activator utilities, there can be only one constructor overload where all of the arguments can be fulfilled via dependency injection. I'll jump back into the tennis booking sample to demonstrate this last rule. Razor page models are an example of components that are activated by the framework using activator utilities. In the index page model, I'll add a second constructor by copying the original one. In this copy, I'll overload it by adding an extra parameter accepting an iBooking configuration. Let's run the application and see what happens. We get an invalid operation exception. The message explains the problem. The index model now violates the rule that dictates the type must only have a single applicable constructor. Both constructors could be satisfied by the services registered with the dependency injection container, and therefore the framework cannot decide which is the appropriate constructor to use. Looking at the stat trace, we can see this error is thrown within activator utilities. In contrast, services resolved from the container directly can support multiple applicable constructors. In this example code, I have a service called MyService that will be resolved from the container. It has two constructors. The first has a single parameter and the second has two parameters. In this example, dependencies from the container can satisfy both of these constructor overloads, so the most parameter-rich constructor will be used to create the instance at runtime. If the another service type has not been registered with the container, then when resolving services to create this class, the first constructor would still be valid and used to create an instance of MyService via the service provider.